Here we're going to look at number 11 from section 1.3. We have a piecewise defined function that uses 5 different rules: x squared minus 1 between -1 and 0, 2x between 0 and 1, 1 when x is equal to 1, -2x plus 4 between 1 and 2, and 0 between 2 and 3. And here's a sketch of that graph down below. We have 4 questions to answer on number 11. First, does f of -1 exist? In other words, can you plug -1 into this function and get a y value as an output? And yes, you can. We can see it both from the graph. That value is 0 when we plug in -1. And we can see it from the rule. This is -1 is less than or equal to x. So we do include -1 in the domain. We plug -1 in, we get -1 squared is 1, 1 minus 1 is 0. I'm going to say yes for my answer here, and I'm going to include a note to myself that the answer is 0. Next, part B, does the limit as x approaches -1 from the right of this function exist? So as we move toward -1 from the right side of -1, are we settling down and flat, or I guess moving to one y value? And the answer is yes to that as well. And I'm going to make a little note to myself. We are moving toward the y value of 0. Part C is basically the question, is A and B the same value? Does the limit as x approaches -1 from the right of the function equal f of -1? And this answer is also yes, because we've made the notes to ourselves that here we have 0 in A, 0 in B, and we're going to say, yeah, that's a 0 in part C. Finally, part D. Is f continuous at x equals -1? So continuity is a well-defined word. It's not something we just kind of casually throw around to describe a point or a function. Continuity requires 3 pieces. We need 1, part A, we need f of c to exist. Part B, we need for the limit as x approaches c of the function to exist. And part C, we need for those 2 things to be equal. So the limit as x approaches c needs to be equal to f of c. So we have each of these 3 things for continuity, except a slight difference. In this question, we have from the right and from the right. And that's because the point -1 is an end point. It is not an interior point in this function's domain. And for a left endpoint, the limit from the right is actually required. So our answer here is going to be yes. This function is continuous at x equals -1 because -1 is an endpoint. So I'm even going to put a note out here that I have endpoint continuity at x equals -1. If we were to look for a right endpoint, we'd be looking at x equals 3 coming from the left, and we'd have to say no because f of 3 is not defined or does not exist. There's no point there. So that's the answer to number 11.